Welcome back. More on two-way designs. The Frender study, we discussed the interaction between the two independent variables. We looked at the no sleep minus sleep difference at morning and the no sleep minus sleep difference at evening. And then we took the difference between those two differences. If you join up the means like this, and if these dotted lines cross or are distinctly non-parallel, well, then that's a sign that this difference and that difference go in the opposite directions or are quite different. So non-parallel dotted lines like this suggests an interaction. We've included in the book a number of figures like this for discussing interactions. And here's an imaginary example about your level of enjoyment in different settings with different types of music. The dotted lines joining up the means, clearly they're strongly crossing. This difference of rock minus classical is much larger and in the opposite direction from this difference, and so we have a very substantial interaction. Let's consider the main effects. Here, when you see a figure like this, you should be able to eyeball the main effect of type of music. There's the mean if we average over setting, party and church, there for rock, and ditto for classical. And so overall, your rating of enjoyment for rock is a little higher than for classical, but to make much sense of that, we need to know what the setting was, party or church. The main effect for setting, party or church, you are giving virtually identical average ratings for party and church if we average over types of music. But really saying that you have similar enjoyment at party and church is misleading, because you could have very different levels of enjoyment depending on what music is going on. Another way of describing this is to talk about moderation. You can say the effect of music moderates how you feel in different settings. It influences your ratings in the two different settings. Or to put it the other way around, you can say the setting moderates or influences how you rate rock music and classical music, and you can describe it either way around. Either of the independent variables regarded as a moderator of the effect of the other. Now a few brief words about a number of examples of more complex two-way designs. This is the Britta-Hölzel study. It's a two-way factorial design with one repeated measure, so it's a randomized control trial. We can also refer to as a mixed design, which means it has at least one independent variable with independent groups and at least one repeated measure. And this is the simplest RCT, 2 by 2. Each independent variable has two levels. So two groups, one meditation and the other control, and pre-test and post-test, a couple of months apart. And the idea was that the meditation group received training in meditation, and then we assessed various things about their mood and so on, and in fact things about their brain at pre-test and at post-test. Grey matter concentration is one measure of brain development. High is good. For the control people who had no training in meditation, there was virtually no change from pre-test to post-test. But meditators, there seems to be some increase on average in their grey matter concentration after their 2 months of meditation training. Think about these confidence intervals and the nature of the two independent variables. These lines joining means, solid lines, indicate that we have a repeated measure, of course, pre-test and post-test, whereas the blue and the red are independent groups. So can we use these confidence intervals to assess that difference? Yes, we can, because these are independent groups. Similarly, those two independent groups. Very long confidence intervals, and so we can't see any indication of any difference because these confidence intervals are so long and overlap so fully. However, what about the comparisons within groups? The repeated measure from here up to here in the meditation group. Imagine the floating difference axis on that difference. Now, that difference might have really quite a short confidence interval on it if we have high correlation between pre-test and post-test, as very likely we do. So this figure doesn't provide what we need to assess the post-test minus pre-test difference, let alone the interaction. To what extent does meditation show a larger increase in grey matter concentration from pre-test to post-test? But we can plot a different figure here where we plot grey matter concentration difference. That's the post-test minus pre-test differences. So for the control group, post-test minus pre-test difference is pretty close to 0, and there's the confidence interval on that difference. Whereas for the meditation group, the post-test minus pre-test difference is about 1, with really a comparatively short confidence interval. So we've got very strong evidence of a positive change in grey matter concentration after the meditation training, and we'd estimate grey matter concentration increase after the training somewhere between about 0.5 and 1.4 on this grey matter concentration scale. Now the difference between that improvement, that change from before to after, the difference between the two groups on that, well, there is the difference of the differences, the interaction, and the confidence interval on that. So it's still quite long, but all the plausible values are positive. It runs from about 0 up to about 1.6, and our main interpretation may be based on this difference of differences and its confidence interval. The Weisberg study is a two-way factorial design with 2 repeated measures. So we had only a single group of participants. Each participant experienced all 4 conditions. They read psychological explanations, good or bad, and may or may not be accompanied by some neuroscience information, which was actually irrelevant to whether the explanation was good or bad. Here we have 2 repeated measures. These confidence intervals cannot be used to inform us about the differences, because on any of these differences we have a repeated measure, and so the confidence intervals on the difference might be really quite short if we've got high correlations. These dotted lines don't indicate a repeated measure. They're dotted to give us some idea whether we've got an interaction. They're distinctly non-parallel, so it hints at maybe there's a substantial interaction here. Let's look at the main effects and interaction. Well, main effect for explanation, the overall mean for good is about there, overall mean for bad is about there. So good is better than bad by, roughly speaking, 1 unit on the satisfaction rating scale. These researchers reported an analysis of variance, and for the main effect of good versus bad, they reported p less than 0.001. So our estimate of that main effect, good, bad, is about 1, and the confidence interval on that estimate of 1 will be quite short because the p-value is 0.001. Maybe we'd estimate this main effect as 1 with a confidence interval from possibly, I'm guessing, 0.7 to 1.3. Looking at the other main effect, which is with neuroscience without, so there's the overall mean with, overall mean without, a difference again, roughly speaking, of 1, again p of 0.001, and so again a moderately short confidence interval. The interaction would be this difference minus that difference, and we could estimate that this is about 0.5, this is about 1.5, so the difference is about 1, and the p-value was roughly 0.01. So can you visualize, think back to Chapter 6, what the confidence interval would be if the effect size is about 1 and p is 0.01. The confidence interval would run from something like 0.4 up to 1.6 or 0.3 up to 1.7. You could sketch it out. Now we're getting a bit more complicated. This is a 3x2 mixed design. By convention, the 3 refers to the number of levels of the independent groups IV and the 2 to the repeated measure IV. So we have 3 independent groups who use different study techniques, and they're all tested immediately after studying and then a week later. The 3R group, this was the one of real interest, the read, recite, review technique for studying. You read it, you put it aside and express it in your own words, and then you go back and check how you went. Or more traditionally, you take notes or you read and reread. And students are allowed as much time as they wished to study the material using their assigned study technique, which was different for each of the 3 groups. Our general analysis strategy, of course, as usual, is to specify contrasts in advance. And here we might decide that note and reread are sort of control or reference conditions, so we might average those together and have a subset contrast of the 3R condition versus the mean of these two, and another planned contrast of the 3R condition here versus the mean of those two at delayed. Can we use these confidence intervals to assess those differences? Yes, we can, because we have independent groups. And it seems there's both a substantial and a very clear difference here between 3R and the mean of these two, and we could estimate the size of the confidence interval on that difference. As usual, we should not just think about numbers as numbers, but in terms of what they mean. So after the week's delay, students using the regular reference sorts of techniques, note-taking and reading and rereading, remembered about 5 idea units, whereas those using 3R, about 9 or 10 units, almost twice as much. So that's a very substantial advantage for remembering material a week later by using this technique. It's this sort of research result that led Mark McDaniel and some colleagues to write the book, Make It Stick, that we refer to so approvingly in the Making the Most of This Book section at the start of our book. Finally, the Chake study, which is a study using mice, 3 groups of mice, a 2-way mixed design, 3 independent groups, and 5 testing times. This figure refers to data from groups of mice given the equivalent of a junk food diet, who could eat freely any time of day or night, who were restricted to eating only during a 12-hour period each day or only a 9-hour period each day. And glucose level is a measure of the response to a big dose of glucose, a sort of sugar hit at this time. And the greater the response, the stronger the evidence of some diabetes-like condition. So these data suggest an enormous increase, particularly in those who were eating their junk food round the clock. Whereas those who had ample opportunity to take as much junk food as they like, but could only eat during a restricted period, 9 hours each day, had a distinctly smaller response. Now, can these confidence intervals help us interpret differences? Well, between the 3 independent groups, yes, they can. So it's quite clear that these differences, which look very substantial on this scale, are quite clear. If we put a confidence interval on this difference, it would be only round about this long or a whisker longer. So we've got very strong evidence of differences between groups. Just eyeballing this figure, and that's always a good thing to do, these lines are fairly close to parallel, so it looks like there's no interaction or negligible interaction. We can't be sure about that because this is a repeated measure. This is really quite an exciting and interesting finding, and so you can see the graphical abstract where the main conclusions of the study are represented in cartoon form at this website. But the general idea is that ad lib eating round the clock leads to risk of obesity and diabetes, whereas you can eat your junk food, but if it's restricted to only a fraction of the time of day, you do better. Or to put it differently, if you fast, eat nothing at all for, say, 15 hours each day, then you are in comparatively better shape than if you have the same amount of food but spread over 3 meals or more. Research can certainly tell us all sorts of interesting and important things. And one of the conclusions I draw is that no matter how complicated the study, if we apply our general strategy of planning contrasts in advance, looking for main effects, looking for interactions, looking for comparisons and contrasts, pre-register these and focus on those, then in most cases we can understand well what's going on. We have a good estimated effect size and confidence interval that we can interpret. Then if you wish, you can explore and you might find interesting things to guide the next experiment.